Large language models have made it easier to prototype AI, where given a general-purpose LLM, users can create a custom ML model by giving it a prompt. However, LLMs can struggle with more complex tasks. For example, when asked to create a list of things to do in Paris and to translate that list into French, the model failed to generate the desired output. Our key insight was that it could be possible to prototype complex tasks by chaining prompts together. We can break down the task from the previous slide into an initial prompt that creates a list of things to do from a location the user provides, a second step that extracts the recommendations using regex, and another prompt that translates each item into French. In PromptChainer, we would have something like this. To give a quick overview of the PromptChainer interface, on the left, we see our overall chain in the chain view, and on the right, we can see the selected node's prompt in the node view. Users have been creating fairly sophisticated chains with the tool. For example, the chain from the previous slide is the backend for a music chatbot interface. In this example, Node 1 is a data input node which feeds in the user dialog that is highlighted in blue boxes in the chat UI. Nodes 2 and 3 are LLM classifier nodes, which will branch into different paths depending on how the LLM classifies the input. In the case of the first input, play music by the Beatles, this gets classified by Node 2 as isMusic, and then as music search by Node 3, bringing us to Node 6, which extracts entities to pass to the YouTube API via a JavaScript fetch. Finally, our output is formatted by Node 8 to be passed back to the chat UI. We wanted to understand how this new tool can integrate with AI prototyping practices. And we conducted a case study with 4 industry practitioners, interviewing both designers and developers. We found that participants used different chain construction strategies, including sequentially implementing each step versus first sketching out the high-level structure. For example, some users might drop in all the needed nodes before refining any given node, while others might try to get the animal classifier node working before moving on to add any downstream nodes. In addition to using different chain construction strategies, participants also demonstrated multiple chaining objectives and needed in-context debugging to troubleshoot their chains. Please see our paper for additional details.